The last thing I want to do is I want to check the energies. So let's work out what the electric field energy is for this solution, what the magnetic field energy is for this solution. The electric field energy is the electric field energy stored in the capacitor, magnetic field energy stored in the inductor. Let's work out what they are. They both depend on time, because remember, the energy sloshed back and forth between all the energies in the capacitor, all the energies in the inductor, all the energies in the capacitor, all the energies in the inductor. So let's see that mathematically. Let's work out first the electric energy. The electric energy in a capacitor is Q squared over 2C. And here's my Q. It depends on time. I square this. I divide by 2C. From here on, I'm going to not write the phi's anymore, because I'm looking at a solution in which phi is equal to 0. So when I square Q and divide by C, I get Q naught squared over 2C times cosine squared of omega naught t. So the electric energy oscillates back and forth, but it oscillates with half the period of Q, because Q is a cosine and the electric field energy is a cosine squared. Now what about the magnetic field energy? Well, the magnetic field energy in the inductor is 1/2 Li squared. And here's my I. So it's 1/2 L times this squared. And so that is 1/2 L I naught squared. So I'm calling this I naught times sine squared omega naught t. And so notice that UB is also sloshing back and forth, but it's going like sine squared. So whenever UE is maximum, UB will be 0. Whenever UB is maximum, UE will be 0, which is what we saw when we analyzed this qualitatively by analogy. Now here we see it fully mathematically. So I want to add up UE and UB and check that energy is conserved. Before I do that, let me use that I naught is given by Q naught over root LC. So this becomes 1/2 L times I naught squared. I naught squared is Q naught squared over LC. So I've got L over LC. And so this becomes Q naught squared over C sine squared. Look at that. UE plus UB, which is to say the total energy in the capacitor plus the inductor, is given by Q naught squared over 2C times co squared omega naught t plus Q naught squared over 2C times sine squared omega naught t. And co squared plus sine squared is 1. So it's just Q naught squared over 2C, which is a constant. So the energy is conserved. Although the magnetic energy is going up and oscillating between 0 and maximum, 0, maximum, 0, maximum. The electric energy is oscillating between maximum 0, maximum 0, maximum 0. Their sum is conserved. And in fact, if I want to write it in terms of I naught instead of Q naught, it can also just as well be written as 1/2 L I naught squared. So the total energy in the oscillator is controlled by Q naught, which means it's controlled by how much charge I dumped on the capacitor at the beginning. And that total energy is conserved throughout the whole story. And that, by the way, you should have expected, but now you can see it mathematically. And I didn't stress that when we talked about it qualitatively. If I make a graph of the energies instead of the Q and the I, so here's T. The electric energy starts out at its maximal value here, and after half a period, here's half a period, it's back to its maximal value, and here it's back to its maximal value, and it drops to 0 after a quarter period and after 3/4 of a period. not so easy to draw. It drops to 0 after quarter of a period and 3/4 of a period. This is UE. UB starts out 0 in the initial conditions, no energy in the inductor, and it rises to its maximal value here and here, and so it looks like this. So this one is UB, and the sum total is just a constant. This constant being Q naught squared over 2C. So this completes our mathematical analysis of the LC circuit, the LC oscillator, completely consistent with everything we learned by comparing it to the mechanical oscillator. And all of you should be wondering something, which is, do real oscillators, do they really oscillate forever? Is the energy really it's just going to keep going on over and over and over again for infinite time, the energy going from electric to magnetic to electric to magnetic to electric to magnetic, current going back and forth, charge going back and forth? That doesn't sound, something must be left out here, and of course you should be figuring out what the something is. These wires have resistance. And we've been ignoring R. This is an LC circuit, no R anywhere. And we have to put the R in. When we put the R in, when we include resistance in this circuit, this oscillation will not live forever. And that's where we're going next.